The idea of dark matter is almost a century old, yet physicists still haven't found out what it is or what else explains their observations. There is one possibility which they don't like to talk about, the nightmare scenario, a particle which is so hard to detect that we'll never catch it. And it's becoming increasingly plausible. Everything we know about dark matter, we only know from its gravitational pull. Dark matter supposedly hovers in a halo around galaxies, and its extra mass makes the galaxies rotate faster. Dark matter also supposedly lingers around in galaxy clusters and makes their constituent galaxies move faster. Astrophysicists also believe that it makes gravitational lenses stronger and that it generally accelerates the formation of structures in the universe. And all of this comes merely from its gravitational pull. Particle physicists, not so surprisingly, believe that what's creating this extra gravitational pull is really a type of particle. If they were bakers, they'd be convinced the universe was held together by cosmic croissants. But the dark matter particle can't be any of the particles we already know of, because they interact with each other too much or aren't heavy enough. The dark matter particle, therefore, needs to be a new particle. And the trouble is that the observations tell us basically nothing about the new particle's specifics. In the lack of data, particle physicists have wishes. They wish for a dark matter particle that does something else besides having a gravitational pull, so that they can catch it in a particle detector, or indeed produce it in a particle collider. Unfortunately, this has not happened despite decades of trying. So what if dark matter just has this gravitational pull and that's it? Nothing else. This is called gravitationally coupled dark matter. It's a nightmare scenario because if this hypothesis was correct, we might just never be able to tell that it's correct. Or to be precise, since we can't verify a hypothesis, we might never find a way to falsify it. And that's exactly the way things have been going. Take, for example, WIMPs, that are weakly interacting massive particles, not to be confused with the particles that make up most internet comment sections. That they're weakly interacting doesn't just mean not strong, it means they interact with approximately the strength of the weak nuclear force. At least that's what it used to mean. Unlikely as that sounds, astrophysicists thought this was correct because of a numerical coincidence known as the WIMP miracle. If you have particles that interact with approximately the strength of the weak nuclear force, and they have approximately the mass of the Higgs boson, then they'd be produced approximately in the early universe in the right amounts to explain our observations. Sounds intriguing? Think again. There are a lot of numbers in physics, and if you multiply sufficiently many in various iterations, you'll always find some coincidences of this sort. It'd be surprising if there were no such coincidences. It still boggles my mind that almost all astrophysicists actually believe that this WIMP miracle meant something. They believed it so much that they commissioned dozens of experiments to look for these WIMP particles, and one after the other found nothing. Each time an experiment found nothing, physicists came up with some explanation for why the particles are just a little more weakly interacting. In case you find that mind-boggling too, better hold your head, because they're still looking for those particles. The current generation of detectors is now 8 orders of magnitude more sensitive than the one that was supposed to find those particles in the first place. We now know that the WIMP miracle is not fulfilled, so even the original motivation is gone. Still, no one wants to say that the idea of WIMPs is just wrong. Still, they keep building bigger detectors. I wonder in what other discipline you can possibly do this. Get a prediction wrong by a factor of at least 100 million. If weathermen were this persistent, they'd still be predicting the Great Flood of Noah. It doesn't look better for other particles that supposedly make up dark matter, notably axions. Axions too are supposed to have a particular interaction, in this case with the magnetic field. They've been ruled out over and over again for decades, and still physicists keep looking for them. They're now leaving magnets on lab fridges just in case the axions want to leave a note. So if not WIMPs and if not axions, then what? Well, maybe the dark matter particles just don't interact with normal matter at all, except for gravity. From a theoretical point of view, this idea is both appealing and unappealing. It's appealing because it's easy to make theories for such dark matter particles. Pretty much any theory that completes the standard model will throw a few into the pool. It also doesn't really matter much exactly what properties these particles have, since you can't measure them anyway. It's unappealing because there isn't much you can say about them. And since there isn't much to say, you don't hear much about it. Gravitationally coupled dark matter particles are the obvious in-your-face solution. But they're incredibly uninteresting. It's much more interesting to talk about the implausible contrived solutions. It's basically the same reason why conspiracy theories are so interesting. It's not because we believe they're true, at least most of us don't. It's because they're so interesting. That Biden had COVID is about as boring as it gets. He died and was replaced by an AI. Now we're talking. Yes, it's not just the case in politics, but sadly in science too, that we talk about speculative ideas just because there's more to talk about. But more often than not, it's the boring answers that are correct and the truth is just dark. This isn't a video about digestive problems, it's a video about the anti-gas lobby, though maybe some of them are getting digestive problems over this. Late last year, a group of about 170 climate scientists signed an open letter to President Joe Biden to cancel plans for a gas export terminal in Louisiana based on a scientific publication that turned out to be completely wrong. Let's have a look. Before I talk about gas, a big thank you to all our supporters on Patreon, especially those of you in Tier 4 and higher. If you have a few dollars to spare, please have a look, because we need your help to keep this channel going. The gas that we're talking about today is methane, the main component of natural gas, or more precisely, liquefied natural gas, LNG for short. Methane, just as a reminder, is an extremely potent greenhouse gas. When burned, it releases energy and leaves behind water and carbon dioxide, which, just as a reminder, is also a greenhouse gas. That doesn't sound great for the environment, but the fossil fuel industry has tried to position LNG as a stepping stone on the way to net zero because it has lower carbon dioxide emissions than coal and oil. For this, they relied on estimates according to which natural gas leaves behind only about half as much carbon dioxide per energy produced as coal, and still less than oil. This is one of the major reasons why the Europeans, especially us poor Germans who don't have nuclear power, are importing gas from the United States, because it's a fast, easy and comparably cheap way to bring down our carbon dioxide emissions. Better still, burning gas causes far less air pollution than coal. Also, the biggest US export terminal in Louisiana is called the Sabine Pass Terminal, so how could I possibly be against it? Then this bombshell report dropped last year saying that actually the climate impact of imported natural gas is larger than that of coal. According to the author Robert Howarth from Cornell University, there are two big reasons for this. One is that a lot of methane escapes along the production line, and the other is that shipping the stuff thousands of miles on boats causes more emissions because, it's not like these are rowing boats. This report was a major influence for the letter to President Biden, and probably also the temporary pause on LNG exports that followed. It was water on the mills of those claiming that the fossil fuel industry is endlessly lying, and the finding also made big headlines here in Germany, because that'd make a great excuse to keep the coal mines open, you see. I actually mentioned this briefly in an earlier episode. What I didn't mention is that when I looked at the paper, I didn't feel good about it. I know that's a stupid thing to say, because who cares how I feel? But you see, this was a single-authored, not peer-reviewed paper that appeared suspiciously at just the right time for those petitioners' open letter, with an estimate that disagreed with everything else I'd read before. But well, you see, this isn't my research area, and I don't want to waste your time, so I decided to keep my feelings for myself. I'm now having second thoughts about this, because Jonah Messenger from the Breakthrough Institute had a close look at the paper and found it to be riddled with mistakes. The Breakthrough Institute is an independent research center in Berkeley, California. Its members tend to be great believers in the power of technology to solve our problems, including climate change. I'm personally very risk-averse and disagree with many of their policy recommendations, but scientifically I don't have a big problem with their views. I'll believe in the power of technology to solve our problems when my printer stops jamming for no reason. Messenger wasn't the only one to criticize the anti-gas paper. Many of these mistakes were pointed out by various other people too, but Messenger wrote a good summary. It's a long list of mistakes, but to just give you an idea, the author of the paper, Howarth, disregarded that gas-powered plants have a higher efficiency when it comes to electricity production. He wrongly attributed methane emissions from oil production to gas production and got some of the shipping distances wrong. Howarth has corrected some of these mistakes now that the paper has been peer-reviewed, but Messenger says that if you correct all of them, you'll get a number that's very much in line with the previous studies. The brief summary is that natural gas, even if imported from overseas, remains clearly favorable over coal. It's not all that uncommon and not a priori worrisome that a scientific paper has some mistakes that'll take a while to sort out. The bigger problem with what happened here is that this was clearly a finding that some activists wanted to believe, so they picked on this one estimate, disregarded that it was conflicting with what other studies had found, and tried to push a policy out of it. I guess the lesson is that confirmation bias is an underexplored source of renewable energy. I read a lot of crap that I don't tell you about, and at the top of the crap list are technology predictions by academic institutions. I'd really like to leave it at that, but unfortunately these predictions are hugely influential for science policy, which is why today I want to give you two examples of pessimistic predictions from one side of the Atlantic Ocean and two optimistic strategy plans from the other side. Can you guess which comes from which side? The biggest issue with the so-called technology predictions is that the supposed experts who make them don't tell you how they come up with those ideas. The first report for today is a collaborative effort of the three biggest scientific academies in Germany. I've only been able to find it in German. Even the English version of the website is German, which is already somewhat distressing. But what's far worse is that they just pull predictions out of nowhere. They select two different approaches to nuclear fusion. That's magnetic confinement and inertial confinement with lasers. Magnetic confinement is the well-trodden path of the tokamak, like ITER or its younger cousin, the stellarator. You try to levitate the plasma in the magnetic field and heat it with radiation until it starts fusing. The latter, inertial confinement, is when you shoot at a fuel pellet either with lasers or particle beams or solid objects. It's what the National Ignition Facility in the United States does. The problems with the German report become apparent when you look at what they write about inertial confinement, because they seem to think it's only been tested using radiation, when in fact I've been preaching for several years now that using solid bullets, like the guys at First Light Fusion, makes more sense. This company has indeed managed to prove that they do get nuclear fusion going in their target. 2 years ago, it wasn't sufficient for ignition, but they're not far away. If I know that, how come that the three-institution expert committee doesn't know that? Did they just forget to mention it? Really, I'm just grumpy because these people clearly don't watch my YouTube channel. Now, look, you might disagree that this is a promising approach, but how do you write an official report that might be presented to the government and just don't mention it? They also forget to mention a couple of other wild approaches out there, like that from Helion Energy, and they lump the Z-pinch together with inertial confinement, which makes zero sense. Did they maybe assume no one reads the report? Now, that'd make sense. They then give you a rating for the technology readiness of these approaches. That's a number on a scale from 0 to 9, where 9 means reliable operation. They declare that magnetic confinement is at level 4 to 5 and inertial confinement at level 3, and then they conclude that according to experts, nuclear fusion won't make any significant contribution to energy production by 2050 and therefore isn't relevant for the energy transition. Experts said it, case closed. Pack it up, folks. Nothing to see here except, the future of energy. If you think that was sketchy, you'll be amazed by the prediction from the Geneva Science and Diplomacy Anticipator, which gives out an annual report on supposed technological developments. About nuclear fusion, it just says fusion investments begin to pay off on the 25-year horizon. Because the experts said so, I suppose. You can contrast this with the plans of the UK government that insists they'll put nuclear fusion power into the grid by 2040. One mission, one vision, one planet. If it doesn't work out with the fusion, they can at least sell the slogan as a motivational poster. The Canadian Nuclear Laboratories also recently put out a roadmap to nuclear fusion. They collected data, assessed technology readiness from that, evaluated the challenges ahead, estimated necessary investments, made predictions for several scenarios, and concluded that by 2035 nuclear fusion could become adopted in Canada and then expand globally. The Germans haven't heard of that either, I suppose. And the Department of Energy in the United States just updated their nuclear fusion strategy, which they call the bold decadal vision, because hey, this is America. If it's not bold, then it's bold. They too think the transition to commercialize will be in the mid to late 2030s. This agrees with what a bunch of startups are saying. I'm not a techno-optimist, I'm a techno-realist. You expect startups to underestimate how long it'll take to get anywhere. And we have previously seen that national strategies and roadmaps are often just wishful thinking. So I'm not saying I believe the Americans. But what the supposed experts seem to be missing is that the technology readiness isn't the only relevant factor to assess how quickly a technology will become reality. You also need to know how quickly it's developing. And the thing with nuclear fusion is that once anyone gets it going, the entire world will drop whatever they're doing and pour their money into it. Because nuclear fusion is going to change everything. It's not going to be a gradual transition. Nuclear fusion, like artificial general intelligence, will be ridiculed until one day it's just reality. Except that maybe at that point we won't be able to tell what's real and what not. Genetic screening of embryos is becoming increasingly widely used, both for diseases as well as traits like height or intelligence. And not just for embryos. The company Nucleus offers to sequence your entire DNA and says they can calculate your intelligence score from it. Though I'm not sure what you do with this score. Put it in your Twitter bio, presumably. Reactions to the idea of screening embryos for high intelligence are foreseeable. Each time a company offers a new test, someone will jump up and yell, Eugenics! Genetic screening has been called the new eugenics, the second age of eugenics, morally deplorable eugenics, you get the picture. Then they'll claim that intelligence testing via genetic analysis doesn't work anyway, and just buying the test is a sure sign you're lacking in IQ, when you should instead be making meta jokes to at least appear smart. The trouble is, a lot of these people are politically motivated. They don't want intelligence to be genetically determined. They don't want others to select the traits of their children. Personally, I think it'd be a very good idea to increase the intelligence of the human species, so let's have a look. Eugenics derives from two Greek words meaning roughly well-born or good good at birth. The term was coined by Sir Francis Galton in the 19th century and refers to the deliberate breeding of the human race for desirable traits. Eugenics is unpopular today because it was popular among the Nazis, who used it as an excuse to sterilize disabled people and to kill those they thought should not breed, such as Jews. If you Google eugenics, you'll find it widely described as pseudoscience or scientifically inaccurate. But, well, we can of course totally breed for genetically encoded human traits. Whether we should do that is a different question, but at this point the question is moot, because while we talk about whether it's a good idea, people are just doing it. Future parents are screening embryos and they are selecting traits, or at least they're trying to, and you can bet that once it'll become possible to genetically alter embryos to enhance certain functions, people will do it. And at least in the United States, the vast majority, more than 2/3, is in favor of screening for diseases. A third is okay with also screening for behavioral and physical traits. Among those traits, intelligence has drawn the most attention, not just because it's useful in and of itself, but also because it's positively correlated with many other factors, including health, educational attainment, and income. Intelligence is also known to be highly heritable, so it must have a strong genetic component. How much do you remember of this week's science news? You can take our quiz on quizwithit.com to find out. Yes, it's difficult to define what intelligence means. Usually these studies are looking at correlations between genes and results from standard IQ tests. I talked about these tests in more detail in an earlier video. And yes, one can debate whether these tests pick up on true intelligence, whatever that might mean, but I think they, broadly speaking, tell you how well a brain functions. The issue isn't so much on the IQ testing side. The issue is that intelligence is also influenced by your environment, and the genetic part of intelligence, like almost all other traits, is not just encoded in one gene, it's encoded in many genes. A study from 2018 found that genetic selection could lead to an increase of 2 to 3 IQ points per generation, so it'd take only 1,000 years or so until we understand why the chicken crossed the road. Several other studies have similarly found that polygenetic scores predicted about 5 to 10% of the variance in intelligence. That's in the range of 1 to 2 IQ points. That's not a lot, especially if you take into account that IQ is massively influenced by nutrition during pregnancy and childhood. A stunning study in China, for example, found that iodine deficiency can cost children as much as 12 IQ points. There's also the issue that the same genes that'll increase IQ will almost certainly be correlated with other traits, and you don't know which because no one looked for it. I talked about the different types of genetic tests and their plausibility in more detail in an earlier video. In summary, I have to admit, unfortunately, that the critics are right. Politically motivated or not, the existing polygenetic screening tests won't do much to make your children more intelligent. At the moment, the best way to have an intelligent child is to find an intelligent partner. Is that also eugenics? Let me know what you think in the comments. The YouTube currency is views. The academic currency is citations. And as I just recently learned, you can buy citations the same way you can buy YouTube views. A team of researchers looked into this newest attempt to play the research game and succeeded in engineering the world's most highly cited cat. Yes, a cat. They started out as a funny and light-hearted video, but it seriously left me wondering if we're nearing the end of academia. Let's have a look. When I say citations are the academic currency, I don't just mean that metaphorically. Citations mean research grants, which mean money. The more often your papers get cited by other researchers, the more important your research seems to be. So, sure, if you could buy citations, it'd make total sense to spend money on it, wouldn't it? And so the story starts as Nick Wise, a fluid mechanics engineer at the University of Cambridge, comes across a Facebook advert. "We help you to boost your citations," it says. "Don't miss the opportunity." They even provide before and after screenshots of Google Scholar profiles. The images supposedly show that citations of several researchers very promptly increased, in some cases by several hundred. An academic facelift, basically. Nick sends his finding to his friend Reese Rickardson, who's doing a PhD on meta-science, and the two have a look at what's going on. Part of the citations, it turns out, come from paper mills. I talked about this in an earlier episode. An entire industry has sprung up producing nonsense papers and selling authorships, usually for a few $1,000s a pop. These papers are then placed into scam journals. Since few people can tell academic gibberish from actual gibberish, these publications look more or less normal unless you really know what to watch out for. It only makes sense that if paper mills are already producing gibberish publications, they might as well sell the citations too. And this is indeed where part of the citations on sale came from. The other part came from ResearchGate. If you haven't heard of ResearchGate, that's one of the more bizarre corners of academia. You sign up with an institutional email and then upload your papers so that other researchers can download them. It's basically a way to circumvent copyright issues with academic publishers. And ResearchGate papers, because they're supposedly coming from people affiliated with real research institutions, get indexed by Google Scholar, which counts citations. So here's how the citation boost works. Upload nonsense papers with custom citations to ResearchGate, wait for Google Scholar to index them, and voila, suddenly you're a well-cited researcher. Indeed, it turned out that a lot of those fake papers with fake citations had not just nonsense content, but were supposedly authored by Pythagoras or Kolmogorov. Nick and Reese tested this by setting up a Google Scholar profile for a cat who they called Larry Rickardson. They computer-generated a bunch of gibberish papers with the cat as author and more gibberish papers that cited the cat's papers. And voila! 2 weeks later, the cat had 12 papers, 132 citations, and an H-index of 11. You might say, well, that's amusing, but rather inconsequential. It's not much of a secret that Google Scholar counts citations to pretty much everything, including blog posts and conference posters. Infamously, it's even listed lunch menus as scientific papers written by the well-renowned researchers C.S. Salad, B. Noodles, and R. Beans. Some of the lunch menus have citations, so maybe we're all trying too hard. Yes, to be fair, this kind of citation spoofing won't fool anyone in a hiring committee or doing a grant proposal review. At least I like to think so. It worries me nevertheless for two reasons. One is that the shortcomings of publications and citations are not as widely known as I wish they were. You may be familiar with Google Scholar, but not everyone is, and some people might fall for fake scientific credentials. The second issue is that what we're seeing here is just the tip of the iceberg. This is the easiest, cheapest, and dumbest way to do it. There are almost certainly much more elaborate scams and frauds going on. Worse still, a lot of it isn't even fraud, it's become normal academic procedure, like particle physicists who try to explain an anomaly will all cite each other so that all their citation counts go up several hundred points, sometimes within a matter of months. Similar trends and bulk citation groups exist in pretty much any other research area. Citation counts are not good measures of academic achievement, but they're used nevertheless. And one of the consequences is that scientific publishing gets flooded with crap because everyone needs to publish and get cited more and more. And that has made it increasingly hard to find valuable work. The only way we currently have to deal with this is personal references. I tell you which papers I found useful, you tell me which you found useful. And that works. It's one of the reasons I'm on YouTube, but it causes a new problem. which is that academic success starts and ends with your personal connections. I'm sure there are lots of great papers that I don't talk about because I just don't know about them. And I'm afraid this is where we'll go. That to combat the problems with scientific publishing, academia will become more and more exclusive and elitist, and in that course, eventually kill itself. But hey, at least we got a laugh out of the lunch lists. Thanks for watching. See you tomorrow.